Hi, this is Leah from Open Intro. In this video, we will learn how to carry out a hypothesis test for a single mean, construct a confidence interval for a single mean, and compare the results of the test and the confidence interval. So here's our problem. Georgianna claims that in a small city renowned for its music school, the average child takes at least 5 years of piano lessons. We have a random sample of 20 children from the city with a mean of 4.6 years of piano lessons and a standard deviation of 2.2 years. A. Evaluate Georgianna's claim using a hypothesis test. So in order to structure our response, we're going to use this I4C framework that stands for identify, choose, check, calculate, and conclude. So first we want to identify the hypotheses, and we're going to test these hypotheses at the alpha is 5% significance level. Sometimes it's easier to first identify the alternate claim. This is the thing that we want to see whether or not we have enough evidence for. We want to see if we have enough evidence that Georgianna is wrong. She says that the average number of years is at least 5. And if that's wrong, if the average is not at least 5, then it's less than 5. So our alternate claim is that mu, the true average number of years of piano lessons for children in this city, is less than 5. The null claim is that that average is 5. So these true averages are unknown. What we have is the sample average, and so we'll use this to test these hypotheses. So now we're ready to choose. We're looking at a mean, and we have one sample, so we'll do a one sample t-test for a mean. Next, we want to check to see how well the conditions are met and if they're satisfied. We need one random sample of less than 10% of the population. And here the problem states that we have a random sample. And so we'll need to assume that the population size of this city is greater than 200, so that we are in fact sampling less than 10% of the population. Next, we should have n is at least 30, or the population distribution is normal. Our sample size is 20, so it's not large enough. So what we would want to do is look at the data to see if it's reasonable to think that the population is normal. Since we don't have the data, we'll have to assume that the distribution of years of piano in the population is approximately normal. And we make this explicit that our results are based on this assumption being true. Now we're ready to calculate. So we'll want our test statistic, t. That's going to be the point estimate minus the null value over the standard error of the estimate. And so here we're looking at, we're hypothesizing about a population mean, mu. And so our point estimate for that is our sample average, x bar, of 4.6. Our null value is what's hypothesized in the null hypothesis. So our null value is 5. And now we need the standard error of x bar. If we don't remember what that looks like, we can look it up. So here we see that the standard error of x bar is s over the square root of n. So s, our sample standard deviation, is given as 2.2 over the square root of the sample size. So that's over the square root of 20. The degrees of freedom is the sample size minus 1. So that's 20 minus 1 is 19. So now we're ready to evaluate our test statistic and find our p-value. In this case, the p-value will be the area to the left of our test statistic because our alternate claim is a less than. It's a left-sided test, left-tailed test. So our p-value will be the area to the left of this t statistic. We can grab a calculator for a shortcut if we like. And so let's see. Here we're going to go to stat, over to tests, and this is a t-test. So I'm going to choose number 2, t-test. I don't have all the data, so I'm going to be entering the stats or the summary stats. Mu sub 0 is the hypothesized mu under h sub 0. So under h sub 0, we're hypothesizing that mu is 5. So that's mu sub 0 there, the null value. X bar, the sample average, is 4.6. S sub x, the sample standard deviation, is 2.2. And n, the sample size, is 20. Our alternate hypothesis is a less than, a left-tailed test. And so now we're ready to calculate. And we get our test statistic at negative 0.813, and then immediately below that is the p-value. So we can record those values. And now we're ready for our conclusion. So what we see is that the p-value is larger than alpha. It's larger than our significance level of 5%. And so because of this, we do not reject H sub O. If we do not reject H sub O, we do not have evidence for H sub A. So what we're saying in this problem is that we do not have evidence that Georgianna's claim is incorrect. We do not have evidence that the average, true average, is less than 5 years. Now we're ready for part B. Construct a 95% confidence interval for the number of years students in the city take piano lessons and interpret in the context of the data. So now instead of hypothesizing about the reasonableness of one particular value, we're going to find an interval of all reasonable values for the true average. So in order to structure our response, we'll use the same I4C framework: identify, choose, check, calculate, and conclude. So the first thing we want to do is identify what it is we're trying to estimate and the confidence level that we'll use. So here, we want to estimate the average number of years students in this city take piano lessons, and we'll estimate it at the 95% confidence level. Next, we should choose the appropriate interval. We have a mean and one sample, so we'll do a one sample t interval for a mean. Check. The conditions for a one sample t interval are the same as for a one sample t-test. So we've addressed these previously, and we've noticed that we do have a random sample. We have to assume a couple things. We have to assume that the population size of this city is greater than 200, and that the distribution of years of piano in the population is approximately normal, since we do not have the data to check and see whether or not this is reasonable. And now we're ready to calculate. So we're going to do the point estimate plus or minus the critical value times the standard error of the estimate. The point estimate is the sample average. We saw that previously. Our critical value is going to be a t star, and the SE is the sample standard deviation divided by square root of n. Okay, so previously we saw that the sample average x bar is 4.6, the sample standard deviation is 2.2, and then we divide that by square root of the sample size of 20. Same degrees of freedom as for the test. And so now we just need to find the critical value t star. So we can grab a t-table, and what we want to do is look at the bottom and find 95% confidence, and then we want to find the appropriate degrees of freedom. So we have 19 degrees of freedom here. So we're going to find row 19 and the column that corresponds to 95% confidence. And we'll see that that's 2.093 is the critical value. So with 19 degrees of freedom and 95% confidence, we're going to use a t star of 2.093. So we can plug that in, and now we have our confidence interval. And so we can evaluate that. If we want to see quickly how to do that on a calculator, we can pull up a calculator here and go to Stat, Tests, and instead of doing t-test, we'll do t-interval. So here's t-interval, number 8. And again, we would want to enter the summary statistics. Those are given there as previously, and just do calculate. And that gives us our lower and our upper bound. Okay, so now we're ready to interpret. We are 95% confident that the true parameter of interest is between 3.57 and 5.63 years. And so what's our parameter of interest? We identified that at the outset. That's the average number of years students in this city take piano lessons. So we're 95% confident that the true average number of years students in this city take piano lessons is between 3.57 and 5.63 years. Now we've interpreted our interval. What can we conclude? We were originally looking at Georgianna's claim that the true average is at least 5 years for piano lessons. And so based on our interval, do we have evidence against this claim? Well, what we can notice is that the interval contains 5, as well as values slightly above 5. So those are considered reasonable values. So because of that, we do not have sufficient evidence that the true average of piano lessons in the city is less than 5 hours. All those values within the interval are considered reasonable. And so now it's helpful to compare the results of the test and the interval. And so what we notice is in the test, we got a p-value that was greater than alpha, and we did not reject mu equals 5 as a reasonable value. Similarly, in the confidence interval, 5 is inside the interval, so it's a reasonable value. And in both cases, we found that we do not have evidence that the true average is less than 5 years. So the test and the confidence interval are consistent. Now we can go further and make a stronger statement, which is that if we had used a two-sided test, which is to say we used the not equal to for our alternate hypothesis, if we use a not equal with our alternate hypothesis, and we're looking at a t-test here, a one-sample t-test and a one-sample t-interval, then the results would be entirely consistent, which is to say that the set of values within the confidence interval that are considered reasonable would be exactly the same set of values that would not be rejected as reasonable values for mu. And that kind of makes sense, right? Because if these are reasonable values, then they should not get rejected. Okay, that's it for this video. You can find more free resources at openintro.org.